Hi, yeah, I'm Joe. I'm from DuploCloud. So what I'm going to talk about today, I'm going to focus on infrastructure as code and CI/CD. So these are basically lessons learned from 100 plus customer deployments at Duplo and many on my own prior to Duplo. And so the subtitle I picked for this one is "Do No Harm." And there's a reason for that. Maybe we'll kind of get into that. So I guess first I'll give a little background on. I mean, maybe not everybody here has heard of Duplo. So some of our founders are early developers of Microsoft Azure, and our main vision is we want to make DevOps and infrastructure as code accessible for everyone. Right. This is a space where there's a lot of specialized skills involved with infrastructure as code, DevOps work. It's not something that all companies have ready to deploy in-house. And so that's kind of what we want to do is kind of just bring this to the masses. So you can see some of our customers listed there. So I guess that considered, I'll kind of give some basics. A lot of us here may already know what infrastructure as code is, but this is basically a methodology for provisioning your infrastructure. And when I say infrastructure, I may mean infrastructure in the cloud. I might mean application resources like configuration for your application. I might mean secrets. I basically mean everything, right? From the network to your disks to your application code that's running, everything. And when we're developing infrastructure as code, we are writing code, right? This is just like application development. We're using a lot of the same principles. We are writing code. We're checking into Git. We're versioning it. We're doing all that kind of stuff, right? And we even may have Kickstarter templates, like to kick off a project, or we might have reusable bits and bobs of code, right? Modules. We might have some scripts that we use to run our infrastructure as code, right? We might even have some internal policies for how we're supposed to create things at our company. And maybe we have some reusable code that is supposed to follow those policies, right? So it really, like the problem domain is different, right? The problem domain is automating what I deliver for my company, but a lot of the tactics and a lot of the concepts are very much the same if you're used to software development, right? So, okay, then we might say, why infrastructure as code, right? What's the benefit? Why would I do this? So, if you can treat your infrastructure like product code, you can actually track all these changes. So you could say that gone are the days where you have a server sitting out there and nobody knows what changes were made to this server. Nobody knows, oh, it works now. Don't touch it, right? let it let it stay the way it is. I don't know why it worked. And then when you go to deploy a new version, you make a copy of the server and you don't know what's there, what the changes were, and you just want to make sure it keeps running. You can get out of that loop with infrastructure as code. Everything is repeatable and reviewable. You can repeat it by running it again in a new org. You can review it by looking at the code, or you can review it even by doing a diff, which we'll talk about a little bit later in the call, right? You can say, how does what is in the cloud right now differ from what my code says should be in the cloud? How are those two things different? And it can show you that, right? You can iterate over your development just like you do with product code, with application code. You can recover to a known good state by running it against something that somebody's changed manually. And you can always have visible what you say your infrastructure should be. So these are really cool benefits, right? This is something that it seems like everybody would want, right? Everybody wants to do. But there's kind of this gotcha, right? This is, now we're in the DevOps world, right? And so one way of looking at this, what is this problem that we've come into? Developers aren't operators and ops are not devs, right? This is a problem we normally come into. And this is an overlap that's hard to find, right? I'm gonna talk about it. I know that somebody from Google has written this book about trying to turn developers into sysadmins, right? This is like kind of the, some people try to turn sysadmins into developers and then make that be your DevOps engineer. Google tries to go the other way, turn developers into sysadmins and make that be your DevOps engineer. But even in both of those two things, you can see the problem, right? Somebody is looking for the unicorn, the guy that is a developer, but knows operations and can use both of those skill sets, right? And that's kind of the unique problem area, right? We want to combine these roles. Most IT teams, they don't have a programming background, so they may know operations forward and backward, they know best practices, they know all those things. But if you're trying to get them to codify it, they might struggle because they don't have the experience, right? They may have tons of knowledge and tons of wisdom, but they've got a hole where that other area is. And then the converse, you can have developers that know all of that. I mean, they totally know how to release software, how to build, make software easy for people to read, easy to iterate over changes, but they don't have all that ops wisdom and experience and knowledge that your IT teams would have. And then there's even other subject matter expertise like compliance and security, right? These are things that maybe neither of these teams might know, right? Or maybe they do, right? These are kind of interesting things. And a DevOps engineer, it kind of sits at at kind of the meeting point between all of this stuff, right? So it becomes a unique problem. So kind of setting the stage for all of that, I thought what I'd do is kind of, maybe sort of tell a story. And this story may seem familiar to some of you guys. It's a heck of a lot familiar to me because I've been here a lot. I'm usually in this spot, I'm usually their DevOps guy. I love putting that in quotes because, you know, when it gets to the heart of things, I'm a developer. I mean, I've been developing for 30 years. The DevOps stuff, I started doing it before they even had a name for it. I do it because I love it, but I don't like being shoehorned, right? I want to do everything, development, DevOps, but those are very rare things, right? And when I started doing this, I didn't realize that it was not common to have somebody that wanted to do all these things. There's tons of talented, smart people out there, but there's less of them that have an interest in all of these areas simultaneously. And that's really important, right? You need to have an interest. So this story became something that would repeat. And so you'll kind of see where I'm going with it. So, let's just look at a typical app, right? Let's say we have an app with 3 backend microservices, front-end web app, SQL database, right? This is pretty normal, not exciting. Let's say, just to cut this story shorter, that the microservices are already containerized. Okay, and then let's say you've got a team that wants to deploy to Kubernetes and they want everything running in AWS. So this team, they've never automated deployments, they've never managed apps in Kubernetes, so they want to hire a DevOps guy, right, in quotes. And so the DevOps guy comes and he writes Terraform to automate all their cloud infrastructure, and he writes a Helm chart to automate their application deployment. And so this is pretty exciting, right? Everybody's happy, like, holy crud, we have a DevOps guy. He wrote all our automation. This is amazing. And so whenever they want to deploy their new code, they just ask their DevOps guy to run it. And whenever they want to change something about their architecture, right? They're using microservices. They want to be fast and nimble. They want to be able to change their architecture whenever they want. They just talk to the DevOps guy and he makes some changes and then he runs it. And everybody is feeling really exciting. Like this, it kind of feels like somebody's waving a magic wand. Like every time they want something, it just appears, right? So this is usually how it is at the beginning of the journey, and people are, having a lot of fun. And the development manager is like, okay, great. We want to start running this from CI/CD. And he's already having visions of in his head of like, articles he's read where people are deploying, 10 times a day to production, and he's going to be that hot, awesome team. And he's really excited, right? So then what starts happening? So we start taking this code that DevOps guy has written, and we want to expose this to some other team members, right? We don't want to just have one guy be a bottleneck, right? We want to be able to have other people do this. So then we start finding some issues here. Not everybody is understanding what this code does. And the DevOps guy is saying, hey, man, this is just code. It does whatever you tell it to do. So let me give you some examples of where they raise an issue to him. A VM gets removed from the code. So the VM gets deleted. The DevOps guy's like, yeah, I mean, this is your code says, I don't want this VM anymore. Of course it should get deleted. You change a path and a port in your app, right? Now there's a brief downtime. The DevOps code has changed that path and port before an underlying config got to get changed. So they weren't synchronized properly. So there was a few minutes where there was a downtime. So these are kind of some warts that are starting to show, right? And everybody's still thinking this code is amazing, right? They're still loving it, but now this magic wand is starting to look a little bit more like a heavy hammer. And it's starting to look like it sometimes could be dangerous. So they're talking to their DevOps guy about this, and he suggests, well, why don't you just limit, this CI/CD that you want me to write? Why don't you just limit it to only deploy the Helm chart, right? Just reduce the blast radius. And maybe if I hit back to this previous slide, you can see he wrote some Terraform to automate their cloud infrastructure, and he wrote a Helm chart to automate their app deployment. So the DevOps guy is suggesting, hey, let's just update the app when it comes time to deploy. Then we don't have to worry about these unintended changes, right? Whenever somebody pushes code, it'll just deploy the app. So that's what they do next, right? They say, okay, let's roll this out to the team. So the DevOps guy says, all right, I'm going to add CI/CD on every push to Git. And what this CI/CD will do is just really simple. It's just going to build some Docker images, and it's going to deploy the Helm chart. Let's kind of skip the UI front end stuff, but it would also be similar, right? You would, on every push to Git, you would build the UI, and instead of pushing Docker images, you would just upload the files to your web server. Like maybe it's S3 in CloudFront, or maybe you're actually using a web server. Whatever it is, it would be similarly simple. So this seems pretty straightforward, and we just roll it out to a dev environment, right? So things are looking good. Everybody's watching it work. Every time they push some code, they see that it works. But the team is looking at this Helm chart, and they're starting to get concerned. Well, what if we forget to make a change to this Helm chart, and our app needs this change, and we go push our code, but we don't push the Helm chart at the same time, and then things break. What happens? Well, could our app go down? Or what if we have made a change to the Helm chart in development, but we didn't intend for that to happen in production, and we forget to take the code out? What could happen? Could our app become misconfigured? So people are starting to be concerned about this. So now the team starts asking some interesting questions. They're saying, hey, is this easier or is this harder? To the DevOps guy's like, oh, this is all basic. I mean, this is easier. Why would it be harder? But the dev manager is starting to worry that all production deployments now have to go through the DevOps guy, right? So we've maybe introduced a bottleneck, and nobody wants that. The manager doesn't want it. The DevOps guy doesn't want it. And the DevOps guy says, well, why don't we have the rest of the team learn DevOps? Isn't that how DevOps is supposed to work? And this is, what we've all read about for many years, maybe even a decade, about this DevOps methodology and getting the whole team signed on to this and learning all these skills. But the manager is looking at this from a pragmatic point of view, and he says to himself, man, I really think I'm going to have difficulty getting the team motivated to take on additional responsibilities. And he doesn't want to start pulling from the budget to hire more DevOps. So what has happened here, right? This is a story I've seen play out many times. And it seems like everybody in this story is trying to follow the standard practices. So how did we get into this state if we were following the standard practices? So that's what I kind of want to, look at here, is like, if we're following standard practices, how do we get there? So let's kind of look at this. Like, what are some of the pitfalls? So some of it is by definition, right? Like, the more infrastructure as code you have, the more that's going to be done for you. So it is done for you. So, and this is where we get to that heavy hammer. It can change it can change or even remove things that you might not expect, right? So it might like upgrade a related system. Maybe your Elasticsearch gets upgraded or your MongoDB gets upgraded, and you may not expect it. Might even be unprepared for it to happen. So then we get to, if this is a heavy hammer, then before you wield it, perhaps you should review a diff or a plan of what it proposes to do. This means inserting a human into the process. So while this does seem pragmatic, you might ask the next obvious question, well, if we put a human in here, how are we using CI/CD? So this is kind of where we get to the lessons learned. So we're not changing or proposing that we change the infrastructure as code. Instead, we're proposing that we change the scope of what is done in CI/CD. And this can differ with organization maturity. But I think for most people, especially people that are just starting their journey, really what you want is application delivery in your CI/CD. I mean, that's generally what your goal is. You want to update your Docker images if you're using Docker delivery app, which I hope you are, and you want to publish your front end assets, right? You just want to get your code out there so the users can use it. If your app requires more changes than that, this is probably because you have an architecture change or a configuration change, and maybe you want that architecture change. But if that's the case, shouldn't you have a person look at it? If you've got code that's going to perform that change for you, shouldn't you look at what that code will change in your environment before you just run it? And then you can decide, hey, is this good? Or is it going to create a downtime? Do I have to do something special to handle this? So this is kind of, what we've learned. If you stick to these simple bullets for application delivery, you end up in a spot where it's impossible to change the architecture by mistake, because you don't even run that IAC on CI/CD. You just run updating your Docker images and publish your front ends. Any architecture change requires somebody to look at it and then manually kick off a process. So I can give some examples here. A very common best practice is an umbrella Helm chart. So I have just like a crazy simple graphic of it. Like the umbrella is this yellow piece. And the idea is that you shrink wrap the delivery of your app alongside its dependencies. So this green box here is your app, and okay, your app needs Postgres and Redis to function. So you shrink wrap it all together in this one umbrella Helm chart. It's very standard and good practice. But think about what it means. It means that it can update all the above. I mean, I'm saying, hey, when I deploy my umbrella version 1.2.3, deploy all this stuff too. So it can do that. And so that means that what if one of these things might get updated unintentionally? What if that's something that you don't want to have happen? There are ways to check that though. There's a plugin, a Helm diff plugin, and I recommend anything that might change your architecture, like an upgrade of your database version. You might want to look at a Helm diff before you do it. I really prefer to use app delivery only in production because it really limits the blast radius. So I try to get away from deploying something that could change the world. Here's another change the world example: Terraform. Very similar, but unlike Helm, Terraform can automate all the things, right? So you can have your resources that you want to deploy in Kubernetes depend on other things like Helm releases, or even things in AWS, right? And the list goes on. I mean, it can go forever how many things you can deploy with Terraform. So I have the same recommendation: always run a plan. This is like a diff. I talked about this earlier in the call. Like, I really want to have a human look at this. What does Terraform say it's going to do for me? And when I look at that list, does that look good to me? If it looks good, I'm going to run it. If it doesn't, I'm going to say, whoa, is there a downtime that might happen here, right? For CI/CD on long-running environments, I want to use app delivery only. I just want to update my Docker images and publish my app code. That's all I want. Terraform even has a nice piece that Helm doesn't. I can, with Terraform, say, hey, just update this one thing. And I can do that with my plan and then do it with my apply to update a small piece of it. There's a little more flexibility there if I want to deliver the app only, but my app is a little deeper than some Docker images and some front-end resources, right? And I actually need to run my Terraform. I can use a command line flag for that. So that's, and so I would be remiss if I didn't show you an example where the heavy hammer is exactly what you want, right? Short-lived environments. I want this heavy hammer, right? Like, here's a great example of PRs, right? I've created a PR. I want a whole new environment. I want my code, my infrastructure as code to run end to end, and then I want to run a test suite. And let's say the PR is merged. I want to destroy the environment. Clearly, you can see here we don't care about unexpected downtimes, anything like that, right? This is actually one of the simplest things to do. Really, then what you're caring about is how much money are you spending, right? How many PRs do you have, right? It's not the simplicity that's the problem. So we've kind of gone over a lot. Let me hit a few takeaways before I open it up for questions. I mean, basically, you can see IAC, infrastructure as code. It's an awesome way to ensure repeatability in what you do in operations, but you can also use it to review or audit your changes. You really should be doing that. Don't run it blindly. Take advantage of that review capability, and never forget that it is a specialized skill. So if you've got a team with, only one guy that knows how to run Terraform, think about that when you come up with your development processes. Avoid a bottleneck where you can, right? App delivery is another example of how you can avoid that bottleneck. If I only do app delivery, if I'm just updating Docker images and publishing, HTML source code, that automatically increases the number of people who can understand what's going on, right, and who can review it for you, and it avoids that bottleneck. Then another thing I would say, it's a good idea to segregate your infrastructure as code projects. This is something I've learned writing infrastructure as code for, almost a decade now. I would say it's a good idea to split out things that you don't run very often, VPC databases, stuff like that. Keep that separate from things that you run often, like your app delivery. That's what you want to do. It makes it so it's much easier for you to limit blast radiuses kind of automatically, even if you aren't doing app delivery only. And then lastly, I would say never forget to ask yourself this question when you're doing CI/CD. Ask yourself, what am I comfortable deploying in an unattended fashion? A lot of times we don't even ask that question, right? We don't say, you know, what parts of this are safe to deploy without a human being looking at it. That's an important question to ask when you're going through this. And this is kind of where you'll see yourself getting to that app delivery only scope. And that's how you can start reducing blast radius, right? And then you get it to anything that isn't covered by app delivery only quite naturally becomes an architecture change, a third-party service change, a configuration change, which is something that you want to have somebody review, right? So that's kind of it. That's where I think you can quickly get a more mature set of CI/CD processes around your infrastructure as code and have it much more likely that you do no harm with your CI/CD. So I guess let's open it up to any questions if anybody has any. Okay, I see one here. Oh, the share button is, oh. Okay, so I have one question. So as a CI/CD newbie, what are the best ways to test or validate things? Oh yeah, I definitely agree with the second sentence here. The most frustrating part of setting up pipelines is waiting 5 minutes for something to not work. Yeah, that's, even if you're not a newbie, that's frustrating, right? It's the stuff like this takes a long time. So it depends on what I'm doing. Like if, for example, GitHub Actions, that's an example of a frustrating thing. Like you can wait 5 minutes for something to not work, but there is a tool, right? There's a tool called Act that lets you locally test your GitHub Actions YAML, and so that's one thing you can do. I would try to break what you're doing into pieces that you can individually test, because if you can show that they're working individually and then the only pieces that you haven't tested are the glue in between them, that really narrows down what hasn't been tested, right? And then you have a lot less to have not be tested while you're there. So let me see. Okay, we have another one. Let me see. Would it be a good idea to start off with something understandable like a shell script with AWS CLI commands, if we're moving to something like Pulumi or Terraform? Yeah, I guess it depends on what you're doing, right? If you have something really small, for sure, yeah. The the benefit, so the only reason you would say for something small still use Terraform instead of AWS, the only reason I can think of is that you can have Terraform actually check for a diff, and with a script you become responsible for the entire state management. So with a script you would have to go look and see, does this exist already? If so, do an update. If not, do a create. Does this exist and I don't want it to? If so, do a delete, right? Those are things that aren't going to be done for you with a script or a CLI, and Terraform will do for you. But if you see that you don't need that level of complexity, then totally. If what you're doing is really simple and you can run a couple CLI scripts and that's all you need, for sure, yeah, you could. It's totally worth it doing something simple. And even if you're just trying to get your feet wet and understand what's happening with the processes, like whatever helps you get the concepts down, you know. Okay, let me see. We have another one. Can you share some thoughts about ops plus dev beyond deployment, but rather operating a service as it scales? Okay. Yeah, I can give you some. I mean, I don't think this is something you could make a whole different topic, right? Like more than just the few minutes that we have left. But yeah, I can give you some thoughts. So one thing, that is different today than it was like 10 years ago, almost every use case you can actually do in the cloud. Like 10 years ago, there were maybe some things that, you know, maybe I should say 15 years ago instead. Like there were, for example, like email, right? If I had to do email delivery for my app, I couldn't run an AWS because the IP addresses could change, right? And so I couldn't whitelist my senders, and simple things like that could prevent you from running in the cloud. Today, uh, there's very little that can prevent you. So then once you get there, and you're in the cloud, you can scale the capacity of your cluster. So let's just pretend that you said Kubernetes, just because I want to narrow the scope to something smaller. So I could say, okay, I want to let Amazon run everything. I'm going to use Fargate, and I'm just going to deploy my services, and I'm going to scale them based on load. That can be so simple when you can cut out so much of that problem, right? You can be serverless and let Amazon handle all of it for you. And you don't even need to know Kubernetes to do that. You could do Amazon's ECS, right? And have so much fewer concepts to understand. And then just start dealing with scaling. But as it scales, you need to be able to look at metrics to decide where you need to scale. Like you don't want to scale prematurely, but you need to be able to look at metrics to tell, like, where is my app starting to fall over? Where might I want to add auto scaling? Find pain points that might cause you to need to change your architecture, further down the line. You need to start getting a little predictive, right? You might see, even in your software supply chain, right? Like not even just the architecture. Let's say you're using software libraries where things are going to start going EOL. And let's say these software libraries are talking to remote systems, and soon these remote systems won't even support these old libraries. And if you don't catch that ahead of time, you might find yourself 6 months down the road racing to be able to deliver your app because your library stopped working. Right? So there's a lot of interesting things that start to matter more as you scale, even just keeping the lights on, right? Okay, let me see. Probably went too long on that one. Let me see. Okay, the concern was about separation between devs and ops. As an op team owns the production environment, how do you see the collaboration with dev? Yeah, so that can often be handled by having some of those shrink wrapped patterns that I showed. Like if you've got dev, and in dev you're doing app delivery only, but you still have automation to deploy your app. If you can then, before you want to go to prod, run a diff, show that your automation is in sync the way it's supposed to be and that you expect it to work in prod, you can then do a handoff to ops and say, okay, guys, run this diff in prod and tell me if you see what we expect to see. And you can kind of do the handoff that way instead of having to, speak commands to people on a call that they type at their keyboard, right? That's the most brutal thing we can do, right? Is when you own dev and they own prod and you have to be on a call telling them what to type. Like you can avoid so much of that by getting your automation written. Okay, so, uh, but I guess, well, before I mark that answered, I guess I should also say we should try to avoid this throw over the fence culture, right? That's maybe easier said than done in some companies, but it really should be that word that you said in your question, collaboration. It really should be centered around collaboration. It shouldn't be like, one team throws over the fence for the other and then, we wash our hands, right? Then we'll never get there. So, okay, I'll mark that one answered. I don't think I have any others. I think that's it. Cool. Well, thank you, everybody.
I had one question for the audience, that both virtual and in person here, which was, is there a way for them to potentially access this presentation at all, or who would they connect on your end to, get smarter in the space further?
Sure. You can contact us at DuploCloud. I would be happy to share this deck with anybody that wants to see it. Or if there's some official way with Startup Boston that, if you want me to send it along, I can absolutely do that. And yeah, and you can also reach me, joe@duplocloud.com.
That sounds great. I don't have any questions on any more on this side. That is, and I'm not seeing any in the chat either. So I think
Cool.
for purposes of day 4 of Startup Boston Week, I think we can round it out. So any last minute thoughts that you want to share, uh, whether with the crowd here or that is on the recorded session that we'll send out later on?
Not that I can think of. I think, this is a lot of fun. There's a lot that we can do in this space, and I think, yeah, I mean, if we just try to, I guess I'll go to I'll plug my tagline: do no harm. If we think a little bit more before we roll something out or roll a process out, we can be sure that we do no harm with the processes that we write.
Perfect. Thank you so much, Joe. Appreciate you taking the time this afternoon.
Okay.